Hey everyone, we would like to talk about video game security today. My name is Anton.
And I'm Bryce. So we're going to take a look at how vulnerabilities of video games have changed everything from arcade games to consoles to PCs to copy protection today. And in the 1960s, when gaming was first coming, there wasn't really an issue of securing video games, and that was because games were being developed for mainframe computers, meaning that these games had to be built for specific architectures, limiting their distribution to only academic and business purposes. We can see this with Oregon Trail, which had to use a teletype, or actually a typewriter connected to a mainframe for its display technology. So when the first arcade games started to come out, these weren't actually computer games, but they were electronic, meaning that all the logic was hardwired, and modifying it would involve modifying the hardware. This meant that the security of these video games were limited to the physical security of the coin boxes, which was the primary way to actually pay for these games. It's really funny because the first arcade games like Pong were using really crappy methods of collecting coins like milk jugs. And Atari would later go on to focus their security efforts on things like copy protection by adding in chips to their system boards. And then we see arcade games move over to casinos, and this was because casinos had seen automated games like slot machines explode. In the 1960s, it represented more than half of their revenue, and this was because assets not only included their physical assets, but also the tourists and the customers that visited them. And they wanted to make sure that no harm went towards these customers because it would bring with it a lot of bad reputation. So as video gaming matured, it came into casinos because it allowed a very natural combating of these vulnerabilities in casinos. We see some examples like video lottery terminals, which automated the slot machines as well as other digitized games.
As video games matured, so did different types of exploits. With the invention of the first early consoles like the Nintendo Entertainment System and the Game Boy, we see the first cheaters taking place. On the right hand side, we see a Game Boy and a cheat cartridge developed by Game Genie sitting in the middle. It acts as the in-between communication between the cartridge game and the console, typically connected to the same port as the normal game cartridge. The reason it's called a cheat cartridge is because it modifies memory values during runtime. As an example, if one is playing a game that has a life counter or a coin counter, the Game Genie would be able to modify those values, probably giving you infinite life, health, or money.
And PCs started coming with their own video games. Network games made their rise to the mainstream with the first Xbox and PlayStation 2. But with it came cheaters, which posed a security risk for gamers for the very first time. This meant that the developers who were coding the game logic on servers had to treat these gamers as untrusted. And this made a client-server model very dominant in gaming even to today, despite P2P or peer-to-peer networking making somewhat of its own rise because it's a little bit cheaper to maintain and there's a little bit less work involved. However, vulnerabilities involve exposing IP, meaning that peers could affect one another more directly, as well as even getting into the game logic and cheating from there.
How much of a game's application logic is exposed is directly correlated with how much you can cheat in the game. As we saw with the cheat cartridge, all of the game logic is in the cartridge itself, and the cheat cartridge can modify it. As in P2P networks, some of the game logic has to live on some peer in order for the system to work. Reverse engineering is one of those topics that is present today, but there's no standardized scheme against it. Game trainers are programs that modify memory of a computer game, and they are able to bypass a lot of measures that companies have tried to introduce against reverse engineering today. For example, even before the invention of memory management units, modern OSs try to come up with a way for video games and the programs that they run to run at randomized places in memory. it would seem that game trainers wouldn't be able to cope with this, but nonetheless, the load address offset can be obtained via via a Linux tool called scanmem. The game trainer uses it to determine the load address and adds it back during runtime. Another example is if a game is using a graphics API, there is a point of weakness that can happen if the cheat modifies the underlying system components. For example, a graphics driver modifying to ignore depth checking will result in all game objects drawn on the screen. This is known as a wall hack, as can be seen on the right side example.
But there's a beneficial side to reverse engineering, and that is modding. And this is a somewhat unique phenomenon that arose as a result of game developers and gamers who were hacking into the games and modifying it, cooperating and creating content for the game. And this was very popular among everyone because it allowed the game to live on well beyond its age, as games, which are typically single player, get multiplayer mods or even get content mods or bug fixes to them. Unfortunately, there's a gray area, and that is emulators. PCs, as they increased in power, also brought with them emulation. MAME was a popular one and one of the first because arcade systems were being phased out and gamers still wanted to play the games, and MAME allowed that. However, obviously, this brings questions of whether it's ethical because these copies of games were typically pirated. It's difficult to expect gamers who wanted to play these games to buy their own arcade system and then get a valid copy off of it. However, emulators and developers of emulators have argued successfully that it is legal because it is their own intellectual property, and therefore companies have responded by releasing their own versions to allow gamers to play older games on official hardware.
Moving on to another big topic of video game security is the digital rights management battle against piracy. A fun example here is we see a customer sending back his copy of a game with a sticker on it to have the company reconsider using DRM. This person, like many other people, believe that the only technical limitation that should prevent them from playing this game should be just that, purely technical, and not some nonsense DRM. So what is a DRM? Well, it is copy protection that allows a company to either control or completely remove user access with what they can do with the digital contents. DRM in many cases is far more intrusive, however, and burdensome on consumers, despite offering a similar and effective impact on piracy rates. Moving back to the 70s, with the invention of the Altair 80, Microsoft developed the first software for it, the Altair Basic. Someone with access to the tape program and a copy machine could freely copy and distribute the program. Microsoft would not receive royalty for the software, although hardware was making money because it was much more difficult to copy the hardware. Now, one cannot prevent the copying of paper or even cassette tapes, but with the introduction of floppy disks, we see the first introduction of copy protection measures. So onto disk copy protection key disks. Microsoft had these so-called bad sectors on the floppy disk that allowed the machine to check whether the original disk was being used or a copy of it was being used. Of course, this type of protection back then instantly prompted the creation of tools designed to neutralize it, because people wanted to create backups. The reason for this is because floppy disk was very fragile. This also meant that copy-protected software was less valuable than non-copy protected software. Off-disk copy protection, and this is another fun example. This requires the user, in order to play the game, to look up something in the manual. With an example of Aladdin's game back in the mid-80s, a user had to look for a specific word on a specific line, paragraph, and page and enter that into the main menu before they can play the game. This proves that the more difficult it is to copy the manual, the more difficult it is to copy the game. However, in all of these methods, if you lose your item, like your manual, your game is left unplayable. Not to mention how annoying it was to pull out a manual or code sheet every time to play. And you could still copy all these methods nonetheless. With the invention of CD-ROMs, copy protection measures started to improve. We see serial numbers, alphanumeric keys, dummy files, fake table contents, etc. fake metadata on top of files to trick CD burning software to think that a file is much larger than it is. However, CD burning software quickly learned to see right past them. Currently, manufacturers moved on to third-party systems for copy protection. Some modern DRM schemes include the following. One of the most hated among gamers is limited install activations. The installation itself ties your game to your hardware configuration. This can be your processor, your motherboard, your graphics card, etc. And as it installs, it sends that configuration info to the server. It is then inconvenient if a consumer has more devices than allocated installs allowed. And it is even more inconvenient if a poor implementation renders an installation use if you just upgraded your graphics card, or even worse, if you just upgraded your OS. Always on copy protection requires the game to be constantly connected to the game's to the game servers. Similar with web-based permissions, this requires access to the internet. And if a user just wants to play a campaign, this is met with controversy if the store campaign mode has nothing to do with the multiplayer mode. Some of the first games allowed only a few activations, 2 or 3. One of the most notable controversies is by Spore back in 2008. It was overly restrictive in terms of activation limits. It required reactivation every 10 days and only up to 3 authentications per individual copy. It actually made the headlines back in 2008. It failed to inform consumers that by installing the game, they inadvertently installed a program called SecuROM. SecuROM is a program for Windows to protect the copy protection of CDs and DVDs. It does its job. It limits the number of times software can be installed on a PC, but it runs with the nature of a rootkit. A rootkit masks the existence of the software, thus proving why SecuROM is difficult to uninstall even after you've uninstalled your game. DRM has had little impact in slowing down game piracy. Indeed, in some cases, use of DRM may make a game into a target for pirates. Spore was singled out by pirates for having such an intrusive DRM. Today's most modern and advanced DRM solutions are not a one-size-fits-all. One example of a modern DRM that tries to compromise between security and accessibility is Denuvo. Developers must integrate their code with Denuvo and mark non-performant impacting functions in their game logic. Denuvo takes these code paths and specifically formulates them to work on a single process environment. A process environment being your processor version, your motherboard, etc. The game then relies on these patches to work and will only work on a specific hardware configuration. This is commonly known as environment-dependent obfuscation. Today, a common way to provide DRM service is to combine it with the community and with the store. Steam has constant sales, a community and social media features, stability, and much more. Steam is unique in the way that people who are against DRMs can still like and buy games on Steam. If you want to play a game, all you need is to activate your game on your account. If you violate the rules, you will get banned and punished.
What's important to know is that platforms like Steam don't provide much inherent security, but they provide incentive to gamers to buy into their system and share their achievements and play games on their platform. And Denuvo actually works with these platforms to get authentication of these users. And Denuvo is actually providing one of the biggest challenges to software crackers in the recent years. But as time goes on, we've seen that software crackers have been able to get into protected games within a matter of days now, which is a serious defeat of this protection. And this represents today's modern battle of DRM against software crackers.